This session is a fireside chat between myself and Ruchika Singh, who is Director of Data Science and Insights at Spotify. Ruchika and I are going to be discussing her approach to predictive modeling and forecasting, and also machine learning in her team at Spotify. So Ruchika is a data leader with experience leading diverse teams of data strategists, analytics engineers, and data scientists. And aside from her day job, she also teaches across New York unis, where she teaches students R, Python, and Tableau. So we're in brilliant hands today. But just before I go ahead and start asking some questions, there's a couple of housekeeping points I just want to make people aware of. So first of all, there is a Q&A box on the right-hand side of your screen. So please go ahead and put in any questions that you have, and we'll try to get back to you after the session. And also, so you know, the session is being recorded and will be available on our on-demand service, which is replay, and that's at cxnetwork.com/replay. But without any further ado, hi Ruchika, thanks so much for joining us.
Thank you, Chloe. Excited to be here.
Yeah, awesome. So I just wanted to start off by asking you to explain your background and what your current role is at Spotify.
So I am a director, as you mentioned. I lead a team of data scientists at Spotify, supporting the Spotify advertising business. We are a team of data scientists, data engineers, analytics engineers who are basically working day to day with business stakeholders to support the advertising function from a data science lens. We want to make sure that every data point that we have around our business metrics, around our advertisers, which is it could be used for business monitoring and alert, and it could be used for data science ML capabilities, is that this team powers every stakeholders with the insights that can be created through data science. Sometimes these are data science models, sometimes these are dashboards, and sometimes these are research and insights texts that can really create good, well-rounded hypotheses to help move the business forward.
Thank you very much. That was a very helpful introduction. So you have explained to me previously that there's no such thing as a perfect data model. Can you explain what you mean by this for our audience?
Yeah, certainly. I have been in this industry for more than a decade, working on data science models, building predictive algorithms, and also working with teams that are highly sophisticated doing this as data science has moved forward in the industry. You may have heard this before. Not no model is right or wrong. Some of them are useful and some of them aren't. While not entirely true, we have a fair bit of accuracy available in model building, and we can train and build great sophisticated models. Really, the secret of building a good data science model is being able to fit your data to the assumptions that we have around the business problem that we're trying to solve. You can have a very, very well predictive model, but it doesn't do anything to your product or your business. It doesn't move a needle. It doesn't make a customer happy more than it was before, and the utility of the model fails. So I think a model that works best, or you can say perfect, is the model that helps you solve the use cases, takes care of the assumptions, make sure that it is balancing between what are you losing and what are you gaining, and that really is a good model. And any good data scientist will say that there is no silver bullet. It always is a work in progress, but you're trying to constantly fit the assumptions better and solve the business problem better.
Yeah, thank you. And how can you go about finding the balance in these trade-offs, so between what you're gaining and what you're losing?
So there are different ways you can balance between these trade-offs. First of all, you have to understand, at the very highest level, what are you trying to solve for? Are you trying to build a model to predict something? Are you trying to do causal inference to understand the underlying drivers of what an outcome are you expecting? So, give you an example, you're trying to forecast revenue for your business, and you can either build a model to predict revenue very accurately so that it can be used for forecasting purposes, or you could really understand the underlying reasons of why certain um, a customer spends versus doesn't spend, and that's more causal in nature, while the underlying data set is the same. It's behavioral data on what you are doing this work, but your goal and your outcomes are completely different. So I think that's the first set of choice that you need to make in terms of what is it that you're trying to solve. Secondly, when you have chosen that this is what we are trying to do, you build different kinds of model. You could build linear regressions model, you could build GBMs, you could build random forest. So the second set of choice that comes as a data scientist is what is the kind of model that I want to build, and that again depends on what is it, how is your metric behaving, how much bias you have, how much variance you have in your model, and how do you trade off between the biases and the variances of the different model outputs that you can. Just to give you some more technical context, when you think about biases and variances in the model, and a simple way to understand biases is you are basically predicting very well in terms of what your accuracy is when there is a low bias um, for a certain data set, for example. And where you but what happens is when your bias keeps is very low, that's great, but sometimes your variance keeps going up, and what does that mean? That means that there is a risk of overfitting. So you might be building a really good model for this particular data set that you're working with, but when you you take yourself out of this data set and you start testing it in other different data sets, your model stops working. So you overfit it for the training data set, but you are now you're not really solving for use cases. So there is a very sensitive balance between bias and variance, and you want to build a model which always has a low bias and low variance, but sometimes it is not possible because you are working with real-time data sets, not theoretical data sets. And so you want to choose that what's that optimal inflection between bias and variance, and what do you want to trade off based on what you're trying to solve for. So whether accuracy is more important or scalability is more important, what is your exact use case will really define a lot of your decisions in many cases. One example is we often build churn models in any industry or any business we work with. So you build churn to predict whether somebody is going to come back and purchase a product with your brand or not. And this is not a very Spotify specific problem, but also applicable to Spotify. And we predict it using ML methods. Different sets of classification regression techniques can be used, but the underlying question that you're trying to solve is what is the accuracy we are seeking? Are we trying to predict who is more likely to churn more accurately, or are we trying to predict who is not more likely to churn? So whether risk is important or non-risk is important, depending on whether you're an insurance company versus whether you are an e-commerce retailer, your use cases will differ a lot. But that is really the secret sauce of saying that what is that balance, and that will determine the choice of the model that you build and how you determine what is the right way to trade off between different considerations.
Absolutely, that makes sense. Thank you. And how are you leveraging these data models to improve forecasting? I know that's something that me and you have discussed previously in your team at Spotify.
Yep. Forecasting is something that is often done both on the demand and supply side of businesses, both for the ads business as well as for the consumer business. And I can largely speak about the industry. It is critical to understand how your business is going to do next year. How do you report your numbers back? How do you plan your workforce, your investments? And it is the bread and butter of revenue planning, to be very honest, for any business analytics and data science teams. Now, depending on how much sophistication has already been into your forecasting process, you can go from like 0 to 100, or you can make more fine-tuned enhancements from 70 to 100. So a lay of the land is you're making a really basic trending model based on some business assumptions, and you have no ML in it, and you're just forecasting for the next quarter or the next year. Obviously, that's not what we do at Spotify, but a lot of companies do start there. And then you start getting into more predictive forecasting, where you're actually using historical seasonality and historical trends and behaviors, historical covariates to say that what is the right forecast from a coming month or coming quarter. That is pretty sophisticated. You have a lot of validation that goes into before you start using forecasting. So let's say that you are in a B2B business and you are leveraging this revenue forecast to plan how many sellers are allocated, how are we dividing our sellers across the business. So you would build a forecasting model for that in that case. If you think about what are the different ways we can forecast, I spoke about a basic model like a seasonality and historical trend based model. There are lots of more evolved techniques or different techniques such as ARIMA that helps you understand what are some of your other macro or non-macro variates are going to be in that particular quarter that will impact. So let's say we were predicting a revenue for 2020, and if we knew that there will be COVID, and if we could bake that into the model, then we would have a fantastic model, but unfortunately we did not. So any forecasting model always has some blind spots because you just don't know what's going to happen in the future. You want to assume and you want to predict as much as you can, and based on how what kind of data you have. But that's the kind of work you do to make sure that you're capturing as much noise and as much uncertainty in the data, and you try and control for it. The other piece to think about when you think about forecasting is what level do you want to forecast. There's obviously like top down forecasting where you're forecasting for the business, for your business units, and then you can also forecast bottoms up where you're forecasting right from to individual customers or individual product lines. So those are the different considerations when you think of forecasting, but there's a lot that goes on at about forecasting within Spotify, outside Spotify. There are a lot of different methods, be it ARIMA, be it just leveraging a profit package or exponential smoothing, or regression based forecast. There is a lot of different ways you can do it. I think the mantra of any predictive model is really understanding what is your business problem, how does your data behave, doing lots and lots of data exploration before determining what is the modeling method you're going to use so that you are set up for success as a data scientist.
Yeah, awesome. And I guess it kind of goes back to that idea of finding the best trade-off as well and kind of figuring out what's going to be most valuable. Thank you. So, Spotify is known for its use of predictions. What lessons would you say our audience can learn from Spotify to improve their own forecasting and predictions models?
Great question. Spotify has been there way before I started here, and they have been using a lot of predictive models. The whole app is built on it. So I can't speak to the whole of Spotify, but I will definitely speak to my experience with my team on how are we using our prediction models and what can we learn from it. So, one of the things that I have learned throughout my career that predictive modeling or ML based methods is not a one time, one and done thing. You build a model, you build more features, you put them into production, you constantly evaluate how they're doing. So it is almost like managing a product of its own, where you have ML based models that feed into your business decisioning, and you constantly improve the models based on how the market is evolving and how your business is evolving. And that is really critical because a lot of times when we go back to the traditional way of building predictive models, you build one model and you never retrain your assumptions, and they just keep being used for years and years, and then it kind of becomes redundant and obsolete. And that's not what you want to do when you're predicting things at any company in your jobs. It's an ongoing process, so stay on top of it. Predictions, predictive tools are great when you know how they will be used. So a lot of product management, traditional product management, goes in building products, right? Like when we build apps, when we build tools which are consumer facing, a lot of testing, a lot of user research goes on to say that what is that user design that a customer will like. But when you think about predictive models that are used for internal business, sometimes we are not doing enough user research. Not talking about Spotify, but just as an industry in general, because it is about talking to your cross-functional partners, your stakeholders. We are going to use these models to build your internal processes and systems. So I think what is really required is some solid amount of road mapping and user journey building, saying that if I build this tool, if I build this signal, who is going to use it? How are they going to use it? How will this improve their business process of tomorrow? How will it impact their workflow? Just the way we think of Amazon as a e-commerce product, and they have personalization built in, and all of their models help us understand what's the next best thing I would want to buy. um, it is because they understand what the customer is doing. If I think about Airbnb, it gives me the right listings because it knows exactly what I want in spring break when I'm looking for a cottage upstate, right? So that is how good predictive models can be if you understand what is the final use case, who is your audience, and how are they going to interact with your model. So my lesson is, whether it is a B2B business or a B2C business, whether it's an internal model or an external consumer facing model, whatever ML use case you have, you want to understand what is the end use case of your model, what are some of the blind spots that you will not see through your data. And if you have that in the back of your mind, you will always end up having an output that is more acceptable, more impactful. In order to do that, you need to talk to a lot of stakeholders. You need to do a lot of documentation upfront, saying that what are some of those questions I'm trying to answer, why is it important, what are some of the hypotheses. So asking the right questions and building the right hypothesis is the starting point to build a good predictive model um, across use cases. And I'm a true believer in over communicating when you're building something which is scalable and big, versus trying to build everything and then go and present it saying that, hey, I have this fancy model with this much F1 and this one recall score, but nobody really understands what to do with it. The other lesson that I've learned is, you also want to know that what is that metric that you're predicting, and how does that metric behave in general. So if you are predicting something that's really volatile and not influenced only by the factors that are in your control, but it's completely macro factored, influenced, then you'll always have that error. And I think being cognizant of what that error will be, and saying that I can improve the accuracy of this model to 75%, and what is the business opportunity associated with improving it from 60% to 75% is very important. You don't want to promise that every model is 95% accurate, but you do want to tell and align and agree with your stakeholders that if we build a model, it brings in additional accuracy, which turns into additional dollars for you, or it turns into additional efficiency for you, and that will place your model in a very, very usable place instead of an unuseful place. As data scientists, I think that's my biggest fear, that I don't want to spend months of my work building something that is not going to be used at the end by people because they just find this little kink in it because, hey, it doesn't solve for my particular use case. And I'm really mortified by that, to be honest with you. So I always tell my teams that let's just figure out how we want to use this model first. Let's write all of that, let's agree with our stakeholders, and let's move forward with it. That always helps.
Yeah, I think what you said about over communication is such a good point. And like you said, it probably is quite mortifying to spend all this time working on this model for someone to then say, oh, actually, you've kind of slightly missed the point of my use case here. Yeah. Okay. So I wanted to move on to discussing unsupervised machine learning. I know that this is something that you're interested in, something that you work on. So can you tell me a little bit about your approach to this in your team?
Absolutely. So, for folks who are listening to this, somewhat not very close to data science methods, I just want to call out what is the difference between supervised and unsupervised. Supervised methods are often methods where we have a labeled data set. What does it mean? We know what we are predicting, whether it is yes or no's, whether it is a certain revenue or sale number. So we actually have a quantified outcome, and we want to understand that how different other features predict that particular label or outcome. When it comes to unsupervised, there is no underlying labeling. So we are just looking at organic data about behavior, and we are trying to say what are those unidentified patterns that exist or relationships that exist within within that data set. Fraud detection or anomaly detection is a very common use case of unsupervised machine learning, where you want to understand that what are some of those outliers that exist in your data set that you cannot identify till you do an unsupervised ML. Um, Oftentimes, unsupervised ML is used a lot um, for machine learning around customer behavior, and we are building all of these customer cohorts. So for example, we want to be able to personalize our email content to people um, based on the underlying patterns or customer segments that do exist. So who is more likely to choose a color, choose a certain product, come at a particular time of the day. Any information that is secure and available to you, you would want to use it to be able to create these customer cohorts or patterns based on unsupervised machine learning. That's a very common use case. Sometimes you often use this for doing feature detection. So let's say that you have 50 or 100 variables that you're putting it in your model and you want to predict a certain outcome. But if you put in 100 variables in your data set, in your modeling data set, it might become too noisy or too complicated. So there is often a step in the middle of modeling process, which is called dimension reduction, which is basically the use of unsupervised ML to group together different variables into like broader factors and say that these are the 4 or 5 factors that are emerging from these 50 variables. And that's also a very common use case of unsupervised ML. Um, I have also seen it being used to understand customer sentiment and review conversations. So, when I was back at the agency, when I used to work with retail clients, they would want to look at the data of all of the customer reviews and say that what are some of the common themes that are existing when a customer calls a call center, or when they're writing a bad review or when they're writing a good review. So you have a lot of context around content and topic mining that uses unsupervised ML for sure. I don't know if you want me to answer further details on this one.
Yeah, so I guess specifically, how do you approach it in your day-to-day job?
I often use it for a lot of outlier detection and dimensional reduction as a part of the broader ML process. I have also used it for building customer clusters. I have used k-means clustering a lot. I have used A rules and association and market basket analysis as part of unsupervised ML. Um, um, People use KNN and many other different features to basically find commonality and non-commonality between your behaviors or the data sets that you're looking at. What my advice would be that there is oftentimes when you're doing unsupervised machine learning, or let's just say very specifically, let's say you are running a cluster analysis, what we often don't have is what does right look like or what does ideal look like. So if I'm looking at a customer base of 5 million people, I don't know whether I need to create 10 customer segments or 5 customer segments or 20 customer segments. It really is a spectrum. And depending on how, how well your clusters look, how differentiated they are on the spectrum, when you map these metrics, you want to identify the right balance. So I think sometimes unsupervised ML is a little bit of business context and arts along with science versus supervised ML, which is much more defined and much more specific. So I always think that always is there. But at the same time, I do believe that there is value in doing a lot of holdout validation, some non-traditional validation that you can run on unsupervised ML, which a lot of new data scientists kind of not do it because, and depending also on how sophisticated your data organization is, what capacity you are working in, I would say being more thorough about how you're validating your unsupervised outputs always goes a long way.
Thank you so much. Okay, so I then wanted to ask you if you can tell us a little bit about how you assess predictive models and how people can go about that in their own businesses.
Yep. There are many factors when you're thinking about model assessment, right? It depends a lot about whether you're thinking about the the performance of the model, the complexity, the scalability, how big is your data set, how are you trying to infer. So a lot of different factors will help you determine how you want to assess your predictive models. But I think the one thing that we spoke in the beginning, that it is not a one-time exercise. So let's say that we are, building a model and you're putting into production. I think you have to create mechanisms to be able to monitor the accuracy of these models on an ongoing basis. So, along with just making sure that is your model is, in production, and it is being run every day, being retrained at whatever cadence you have decided. As a data scientist, you need to say that how your accuracies are moving and trending as your model is being used. That is probably one of the most important things. I think the other piece you want to think when you're thinking of at scale predictive models is about managing and building clean and good data pipelines that supports it, being able to scale it, being able to integrate it with other systems and tools where it may be integrating. So it's sometimes once you have a model, how do you build an API to be able to put this into different end user systems where people can use this as a part of their ongoing workflow. Also, I think a lot of user feedback, a qualitative user feedback and user research always helps bolster and reinforce the kind of work you're doing. Because as we spoke about, a lot of information is not captured in the data points that we have to build the model. Sometimes these are implicit, existing in the heads of people who we are building for. And that kind of qualitative user feedback, either through quantitative research or through qual research, helps build those assumptions and make sure that you're controlling for it in one way or the other. I think that's super important.
Yeah.
uh, and then I think mixed methods is a thing that is very, very popular at Spotify, where we look at data science and qualitative and quantitative research at the same in the same bucket. So we are almost building things from an insights perspective, where you have data science as a pillar and then you have user research as another pillar, and they feed into each other, because from research you can create hypotheses that you can test and validate and build towards from data science. And then you have these unidentified or unknowns from the data science world, which you can take it back to the user and market and say that, hey, I want to talk to you all about, because this is something that we don't know how to answer. And that combination is really a powerful method. It's a known method, but it is pretty popular at Spotify.
Thank you very much. And then finally, what would you say are your key pieces of advice for companies and organizations seeking to improve their data strategy and to really build a culture of data?
Yeah, probably my favorite question, Chloe, in all of these. I have built different teams of different sizes and scale throughout my career. And one key piece of advice for anybody who is in data science or trying to become a data science leader is to be able to know how to make allies within your organization who will help you shape and progress the narrative around data. And this is not a one way to do it, one size fits all approach either, because it really depends on what is the type of your organization, and that will decide what data strategy you might want to go for. You might be in a organization where data has always had a critical role, and it's a young company, and you know how to deal with data, leaders know how to work with data, and your approach to building a data science team might be completely different versus a service oriented traditional company that hasn't really looked at data as a critical part of their day-to-day operation, and you're building from ground up because you now need to not just build data products, but you also need to train your people to use data and to take decisions using data. So it just depends on what your goals are, but having friends in other cross-functional teams that understand the value of what data teams bring to you and working with them hand in hand really helps you make the most impact and maximize the value of data to the organization. I think the other thing that I've learned is how do you cultivate diversity of skills and thoughts in your teams. to make sure that people have different opinions about how you approach a problem space, but they also have different opinions from a cultural standpoint. So I think building a diverse and inclusive team is as important as it is spoken about, and it's not just a people management goal, but it's actually a goal for people to bring better products and better data solutions to teams. um, and also give them space to grow. Oftentimes we build teams that are focused so much on impact and business alignment that we forget that these are data scientists who are trying to build and grow their careers in a space that's highly dynamic. And they want to learn and grow every day. They want to pivot, they want to change their specialization. And as a data science leader, that is something that you have to almost keep at the back of your mind, that what does my priorities look for the year, look for the quarter, how will this bring value to the business, but also how will this make my team happy and healthy, because they are your biggest assets. If you don't have good data scientists going for good work, it falls flat. All your ambitions will fall flat as a leader. So definitely keep that in mind. And the last but not least, I often say that asking the right questions, making sure that you're being able to communicate and ask the right questions, solve problems with your stakeholders, create a roadmap of what will this look like in the next year, next 3 years, really helps shape the function of data within your teams. So never lose sight of it as a leader. Don't go over technical, but also um, don't go the either way. So there's always balance and equilibrium that's needed to build a data team.
Thank you so much. That's really good advice. So, Ruchika, this has been such an interesting conversation. I really appreciate you joining us here to share your insights and all your advice and give us a bit of a view to what you're up to.
Sorry, can you repeat that?
Yeah, no problem. Sorry, I was just saying thanks so much for sharing your insights and for kind of giving us a bit of a view of how you approach these issues in your role. It's been really valuable conversation and I've really enjoyed it.
Likewise, you don't really know how much you know till you actually speak about it. So it was a great conversation.